Hi, it's Paweł. Welcome you to the next episode of creating sample Golang server application. In this episode, we will integrate a Postgres database provider. To do so, we will need just a few things, like adding one more provider type. Then we will need to register it. We will also need to implement a database connector, which will allow us to actually connect to the database. And we will finally we will need to utilize that connection to make some requests to Postgres. Before we started, I have added a few items to Docker Compose, which is Postgres database for test purposes. It comes with a pre-installed schema for this system, and I have put services for in-memory and Postgres tests. As you can see on the bottom, I have run in-memory test for verification, and we have it running green, so it should be working well. Also, in the meantime, I have modified types of requests for create and update the object to minimize the amount of data that is being pushed there. And so we instead of putting the whole resource, we only provide metadata here, as we don't need the other items here. So to get it started, as mentioned, we need to start with adding a type of provider that we want to support. So let's add a Postgres provider type, and let's use it here with a trace to return the correct provider in case of using Postgres instead of in-memory. As we can see, it's not reporting an error because I have already prepared a template of the methods. We will need to implement the actual business logic for it. So the database connection and the parsing of the data. So as we have it prepared here, let's build the actual instance of our Postgres client. It will be a singleton, same as with a server or provider. So I have simplified it a bit with a template. We will need to use some connections string for Postgres, obviously. So host, port, user password, and the name of the database that we will take from environment variables. And what we do need here, in case of we don't have an instance yet, besides of obviously logging that we are trying to build such an instance. Okay, we will try to open a connection pool of the type of Postgres. SQL Open supports quite a big amount of different drivers. So we have a choice here. I have chosen Postgres for starters because it's quite nicely support bit files, bit binary objects. There is a possibility that in the future there will be more of such databases supported, but first things first. What is happening here? In case of error, we want to shut down the application, as we can't really use app with Postgres provider without Postgres connection. Also, it could be improved with let's wait for some time until we get such a connection, and I will do it in some time. For now, let's assume that we have Postgres running somewhere. And what happens in case of a fatal error happening? We print that error to console or file, and we shut down the application with code 1. And what else? In case of it works, so we managed to connect to Postgres, we will need to set 2 parameters, which will limit the amount of connections that the collector will try to keep open. By default, it takes quite a big amount of such. The connection is over 100, and it limits the usage of the application it limits it badly. Like that, we have a chance to actually use it for some more than one instance, and it actually works. So it's worth to put something, and for me these numbers work the best. Okay, so we have our database available and ready to be used. So we will just need to run a few queries to finish up the implementation. Let's start with some util function that we will need in a few cases, which is the count of our resources, the total amount of records in the database, in that particular table at least. We will need to create the client for our PostgreSDB, and we will need to get one integer from the query. And how it works for this library, as we want only a single item, we call the query row, and we build a select request. Count everything from resources provider resources, and we need to call a scan function, which will put the result to a list of fields that we have defined for it. And in case of error, we will log that something failed, and we will return -1 as we haven't found anything and some error. Otherwise, we will return that count that we have collected and no error. This will be useful for a few cases later. So let's get to the actual implementations. Let's start with that single resource by ID. It takes an ID and returns either a nullable resource or some error. We will have the same client here, so let me just copy it. And we need a resource instance And here the query will be a bit more complicated. Let me also just copy this element, so as it might take some time to rewrite it. So I will just shortly explain what's happening. Of course, we need to use some additional library for it. Besides of the natively supported SQL, we need to support Postgres itself, which is libpq. And now we should be able to use these additional functions. And what happens here? We also call it a query row, as we are interested with a single record of type resource. And in turn, we map every field from resource to a matching field from the database. And in case of error happening, we log something and return nothing and that error. And if it worked, we can return that build resource. Let's get further and let's try to get the content of our resource. It also needs a string ID, and it should return a byte array, which is the file content. It also will need a client build, and it will want a resource byte array. In case of error, it's also query row, as it's also a single item being downloaded. So we want to select content from resources provider resources, where ID is the first query parameter, and here we will pass that ID, and we will scan it to get the resource content. And if we catch some error, then just as before, we will log it and return nil. As it's an array, it defaults to nil, so we don't need to put a pointer here. So it's sliced, so it does default to nil. It is already nilable. In case of structures, as you probably notice, we need to put that asterisk to mark it as nilable. Okay, we have something. Let's continue. Let's get the list of all the resources available. It for now takes only pagination object, and it should return paginated resource. This case is not nilable, as we always want some response from this one. And here we will use that the count of the items. If that fails, then we will return some default answer. Here we will put nil for resources. Basically, we don't need to put it here, but let's keep it for better readability. And if it worked, if we got total amount of items correctly. Then we will obviously need a client. And we will need to build the pagination with the amount of items in total. And we will try to get the rows from the database. In this case, it's not a single row, but collection. So it's query instead of query row. That's how the select query looks like. We get a collection of rows, and what we want as a result is a slice of a type of resource, and we will initialize it as empty one, and how we handle multiple rows is it's a sequence basically. So for each next, so we will iterate through all the items we have obtained. We will get some resource, and in case of error, we will try to make a scan for each item. In case of error, as before, we will load it and return the empty result set. If it worked, we will append the list of resources with that for a new one, and then if all the for loop manages to pass, we will try to return the build slice as resources inside this paginated result, and no error here. Okay, for more items to go, and we get to building or updating items. And here let's start with upload the content of the resource. For example, we need to pass string ID and byte array content, and it should answer us with integer being the amount of rows that were updated, so 1 or 0, and error or no error. And as it's update query, then we will call edz here, and here we need just to put an update resources provider dot resources set content equals assign to a second parameter where ID is the first parameter, and here we need to pass ID and content as the query parameters, and in case of some error, we will load it and I probably have some typo here. Let me check quickly. Yes, there shouldn't be a bracket here. Now it will be just fine. And we want to return 0 as no rows were updated, and error. It is obviously propagated further to the controller and parsed to the HTTP response by what we have prepared in the previous videos. Let's continue with building a new object. It's another quite a big one, so I will copy most of the implementation. As what we need here is to pass that metadata that we will use to build database row, and we need to generate a unique ID for it. I'm using before bash for UUID. And what happens here? Let me just copy the content, as it's just another edge. Here there is one more point, as we use time pinpoints, which is array of structure, and we don't have native support for it for custom objects. In the database, I have it defined as such a custom object, and to actually have it supported, we need to add some additional functions here. So let's do it now. It's a simple structure with 2 fields, so it shouldn't be the hardest one. It's just 2 functions as well. One for building it to PG array, and one to scan the result. So what do we have here? It's the list of items as a string array of the length of the input list, and for each item here we will append that slice with formatted string, which contains a proper implementation of Postgres array, which is in this case a number and a string filled with TP moment and TP description. And that's all we need to convert a list of structures into a Postgres array. A bit more complicated is the opposite case. For that, we need to override or extend the scanning mechanism. So implement a scan function for this given type. Also here we don't operate on a list, but on a single item, as each one would be parsed using this function. And what happens here? We try to obtain source bytes, and here we call casting to uint8 list from that interface. It should work. For the normal traces. If it doesn't work, we obviously want to throw some exception, as it's not the type we are looking for. And if it is what we want to work for, we firstly parse it to string, that byte array. Then for each of these items we have here, which is some list of what we need to filter. This one. Probably I have some one more typo here, because it shouldn't be failing. Let's put it in a second. So our source will be strings replace all of these inputs into an empty string. So we don't want any of these items to appear in our resulting string. Having that cleaned up, we will split it by commas, as you have seen above. We have that array built with commas, and one more thing here is to verify if a moment, which is supposed to be a number, indeed is a number. And for that we will call strconf, which as the name says, it's supposed to convert the input string input to in this case integer of a base 10 as a number system, and a bit size 64. If we have some error, then obviously we want to return such an error, that we failed to parse our desired type. And if it worked, we can assign the value of our TP to build structure with a moment and description. As it's a string, that's a certain one, we don't need to specifically verify it. We can if we have some constraint, for example. And we want to return nothing in this case. Okay, so that should make it for building a new object. We have just 2 more items to draw, which is update and delete. And let's make it fast, as I don't want to prolong this video too much. So I will just copy this in these items. For update, we do basically the same as what we do for create, besides of we don't need to build new identifier, and we use set for each of the fields. We also need to parse the time pinpoints array to Postgres. And for delete, which is quite a basic one, we just call fz with a single delete command. It should be all what we need for Postgres implementation as for now. Let's try to run test suite for both providers to check if it does work. Still, I'm missing something. What's that? Okay, I have a typo. So let's try to fix it, because it should be fine. Maybe the instance of Postgres is not exactly initialized, although it should be working. Let me check in my sources. Right, I had additional S here. And I have the same in the in some of the other items. I have forgot how I named that schema. So as you see, it does work. It was just my mistake that I've confused the name of the schema I use in this database. Okay, so what we managed to implement is a storage provider for Postgres database, which lets us store the whole metadata of our resource and its content. And as we have managed to check, it works. So it's ready to use with Postgres. Thank you for your attention. What should be happening in the following videos is support of validation of our domain. So I will add a library that allows to validate the arbitrary objects, and then in the next one we will extend the system with some user control, which is some basic authentication and authorization of the requests. So see you on the in the I hope close future.